In Unreal Engine modding, everything revolves around two massive global arrays, GNames and GObjects. If you want to make a mod, you need to find them. Today, I'm going to show you exactly how to find them from scratch using Ghidra. More importantly, I'll show you how to create byte signatures, a method that is vastly superior to hard-coding addresses because signatures actually survive game updates. First, download Ghidra. Make sure to get it from the official GitHub page. You'll also need to install the Java development kit for it to run, so just follow the instructions in the official README. Once installed, open ghidrarun.bat and close out of any tip windows. Click File, New Project, choose Non-Shared Project, give it a name, and choose where to save it. Next, open your Rocket League installation folder and drag rocketleague.exe directly into the Ghidra project window. Leave the import settings on default, click OK, and wait for it to process. Double-click the newly imported executable. Ghidra will open the code browser and ask if you want to auto-analyze the file. Click Yes, leave all the default options checked, and hit Analyze. Rocket League is a massive game, so this process can take about 10 to 15 minutes. Wait for the progress bar in the bottom right corner to completely finish before moving on. Once the analysis is done, we can start searching for the offsets. We'll start with GNames. Go to the top menu, click Search, select for strings, and hit Search. When the list populates, go to the filter box and type byte property. Why are we looking for this? When Unreal Engine boots up, it has to register all of its default engine names. Byte property is one of the very first strings the engine uses. In the search results, double-click the string that has a label next to it. This takes you to the data section. Right-click the string, go to References, and click Show References to Address. Double-click the result that pops up to jump to the actual code. Now scroll up slightly until you are near the start of the function. We are looking for a variable that starts with DAT_14. A good trick is to look for the hex value 0x80000. Right above that, you will see the DAT_ variable we need. Ghidra uses 14 as its default base address. We only need the offset, so just ignore the 14. The remaining numbers are your GNames offset. Write that down. Now for GObjects. We will do the exact same string search process, but this time search for max objects not considered by GC. Follow the references to the code just like before. Once you are in the initialization function, scroll down until you see some memset calls using the value 0x40000. Right above those calls, look for an instruction moving a DAT_ variable into RCX. You will usually see 3 of them grouped near this place. Just like before, ignore the 14, and the remainder is your GObjects offset. So how do you verify that these offsets are actually correct? You will need a memory scanner like CEngine. Open it up and attach it to a running instance of Rocket League. Click Add Address manually. In the address box, type rocketleague.exe plus followed by your offset. Because Rocket League is a 64-bit game, make sure to check the box to set it as an 8-byte pointer. Do this for both of your offsets. To check GNames, right-click the address in your list and click Browse this memory region. If you land in a section filled with a bunch of readable engine strings, it means your offset is correct. Do the same thing for your GObjects address. You should land at the start of a massive list of numbers. The memory right before the address should be zeros, and as you scroll down, you should see a repeating structure in the text section on the right. These are the pointers to all the objects in the game. Now let's talk about signatures. Unlike hard-coded offsets that break every time the game updates, signatures are dynamic patterns that find the new offsets automatically. The easiest way to generate these is to copy a chunk of the assembly code from Ghidra and paste it into your AI of choice. Ask it to explain the logic and generate a strong byte signature for you. To understand how they work, think of a signature as a unique fingerprint of the code. It's just a sequence of hex bytes representing the game's instructions. Before you use a signature in your code, you need to test it to make sure it works. Go back to CEngine and attach it to Rocket League. Change the value type to array of byte and check the hex option. This next step is crucial. In the memory scan options, make sure both the writable and executable boxes are set to Don't Care. On Windows 11, this looks like a blue minus sign. If you don't do this, CEngine will ignore the game's code and you will get 0 results. Paste your signature and hit First Scan. If your signature is strong, it should return exactly 1 result. From there, you can right-click the result to disassemble it. When you scan the signature, it returns the location of the code, not the actual array itself. To get the actual GNames or GObjects address, right-click the search result and select Disassemble this memory region. This will open the memory viewer. Look at the highlighted assembly instruction. You will see a command like LEA or MOV, followed by an address inside brackets. It will look something like rocketleague.exe plus and an offset. The address inside those brackets is your actual pointer to the array. Note down that offset. Now go back to the main cheat engine window and click Add Address manually. Type in rocketleague.exe plus, followed by the offset you just found. Set it as an 8-byte pointer and click OK. Now you have the actual data address. You can right-click it and browse the memory region to verify the strings or objects exactly like we did earlier. And that's it. You now have the offsets and the update-proof signatures you need to start modding. Thanks for watching.